My name is Jean Coupon, and I will talk about artificial intelligence for warning messages that are called NOTAMs at Swiss International Airlines. First, I would like to tell you a bit about my background. I'm an astrophysicist. I did a PhD in 2009. I spent 4 years in Japan and Taiwan, and I've been working at the University of Geneva for 5 years now, working on a project led by the European Space Agency. But I think that data science is really cool, it's very promising. I think there are a lot of new opportunities, and I'm seeking to work on business-driven challenges. So that's the reason I've done this program at Propulsion. So my project was about warning messages in aviation. And I'm sure that many of you have experienced delays in your flights. And this might be because the airport you are going has a closed runway, for example, or there is a hot air balloon event somewhere so that the plane has to divert and this will delay the flight. All of these events have to be notified to the pilots. And this is done through a system which is called NOTAM, Notice to Airmen. And this is a short text that is issued by aviation authorities. It's been there for almost a century now. And the pilots are responsible for collecting the relevant ones before taking off. But usually for commercial airlines, this is done by people there and then handed over to the pilots. This is what a NOTAM usually look like. There are two main parts. The first one is a code that tells you about the location, the time, and a basic description. And the second item is a text in English. It has a free form, you can have abbreviation, and it gives more detail about the kind of event. The challenge that Swiss is facing is that there are 3,000 NOTAMs going every day that has to be deciphered manually by the people there. And so as you can see, this is pulled from a database, and then there's a NOTAM officer that comes to the airport very early in the morning, like at 3 a.m., and then goes through this classification and suppressed about half of it, and the rest is given to the flight dispatcher, and then the pilots received, on average, between 70 and 150 NOTAMs per flight. So the goal of my project was to try to help everyone in the process to make informed decisions in order to save time with obvious NOTAM that can save money to the airlines and to spend more time on uncertain cases to keep the safety standard very high. So I did two things. The first one is I worked on labeling the NOTAMs. The second thing I did was to sort by importance. So essentially the goal was to transform this pile of NOTAMs that is handing to the pilot to something which is more readable, that has a label, and that has an importance where you can sort the different message according to that level of importance. So the first part was about labeling the NOTAMs, and what I did was an unsupervised machine learning approach in 3 steps. The first one was to transform the words into something that a computer can understand, so basically numbers. The idea is that you have to transform these text messages into vectors, into numbers that the computer can do. And then I trained the model in order for the computer to find the similarities between these messages, and finally I did the labeling by hand. So here is an example of all the NOTAMs for 1 week, so each point represents one single message, and here we have the representation in 2 dimensions. Like the dimensions here don't mean anything, but you have to understand that if 2 points are close together, it means that the computer thinks that the 2 messages are important. So for example, we can look at this cluster here in gray, which is that runway is closed. The next point is also about the same topic, that the runway is closed. Then we can move on to the blue cluster here, and it says that it's about the crane operating. There's another obstacle here. And then if we go to the next point, is also an obstacle. So the algorithm is understanding that this cluster is about obstacles. But of course, the model has its limitation. And if we zoom into this cluster here, we say here that every time we have these 3 words will take place, but the topic is different sometimes, which means that the algorithm is understanding that something is happening, however, it doesn't understand what is the exact topic. The second part of my project was to do classification of importance. So you must remember that all these NOTAMs are pulled by the NOTAM officer and then classified into important and then or unimportant and are then suppressed. I trained a model, a supervised machine learning algorithm in order to define an artificial intelligence system that will do this classification, that will set an importance probabilities to each of the NOTAMs. So for example, one workflow we could think about is that we can train this classification that was done in the past, and the day after, when the new NOTAM is coming, it can directly be assigned first a label from the previous work and then a probability of importance between 0 and 100%. So, and this, all this process will help the NOTAM officer to make informed decisions about the classification of the further, of the next NOTAMs. I did test my model on the sample for which I knew the answer. I ran the model and then I had 94% accuracy using a neural network trained with only 1 month's worth of data of NOTAMs. So to summarize, we've seen that processing NOTAMs is tedious for Swiss and we want to help. And the idea and the approach I took was to write an AI system to label and assist classification so that it has the potential to save time and then money to the airline while keeping safety very high. What we can do in the future is train with more NOTAMs in order to improve the accuracy of the model, and we have millions of NOTAMs available already. And then we can also improve the model tuning, like for example asking experts to help us doing that. And then we can tune the different parameters in order to get a better accuracy. And finally, something which is also very interesting and very important is to get the feedback from the users, like the pilots, the NOTAM officers, and how this very simple question, how can we help? What can we improve in order to make their life easier? And I thank you for your attention. Okay, so the question was about improving the accuracy compared to what's done manually. But the problem here is how you define importance. And for example, if there is a crane at the end of an airport, like for some people it will be important, but for some other people it won't be important. I talked to a pilot last week who told me that he received this message on his document saying that there was a crane at the end of the runway in Los Angeles, and he's like, I don't care because it has no potential. It's not potentially dangerous for my flights. So it's a subjective matter.
Did you play around taking common words out, like because you had this example of it will take place? I guess this also changes your model.
Yes, you're right. So that would be a lot to improve. So the way I run this clustering is that I defined a metric, which is the cluster purity. And what I try to do is that every time I would define a cluster, I would look at what is the purity, what is the ability of my cluster in order to determine if it's important or not important. And for this specific case, I choose a model which is called word2vec, and it's used the embedding of all the words. So like these words, because they are coming together, then they are associated to the same idea. So one way perhaps to do that would be to combine these words, or to remove it. Yes?
How did you combine multiple words from a single text? Did you sum them, for example, average them?
Yes, I did. So I did the word embedding. So for each word, I'm training a model in order for the computer to understand how the messages are related to each other, how the words are related to each other, and then I average over the vectors of the words for one single NOTAM. Yes?
So about the outlook, do you already have some plans or design for how you want to improve one or some of your accuracy?
Yes, that's also a very good question because so in this specific case, I used two different kinds of features. The first one is the vectors from the words themselves, but I also added the different codes. And in the codes, you have a lot of information, but sometimes you may dilute the information because it contains information on the position on the Earth and things like that. So one thing that I would do is to try to find which codes, which features are more important, and play with that, essentially. And of course, with that many messages, something that we could try is deep learning, so that instead of doing feature engineering here, which is also a lot of work, we could just put the messages as is into a deep learning system, and that the system would learn how to clean and pick the most important features. Yes?
So were you able to incorporate the coordinates of the route specifically?
Yeah.
Of
So,
the flight?
yes.
So with the pilot, when you said that it wasn't relevant to him, so were flight coordinates used?
Yeah, so in the codes, there's the position. So the sky is divided into sections, and that depending on the section, the nature of the messages is also different, right? And so by putting this information on the location, I can also improve the classification.
Sorry, Joel, to move on.
All right. Thank you.